us in joining our next speaker from the College of Engineering and Physical Sciences, Adel Hamid Al-yoorby.
To begin, I would like to ask you all a question. How many of you have heard of quantum mechanics? How many of you have seen on the headlines that we've made a quantum computer that solved a problem in such and such time? Quantum mechanics is not just science and mathematics. It's a revolution that will change everything. Computing, communication, and even our understanding of reality itself. I wanted to explain quantum mechanics in simple terms, but then I remembered, even Einstein called quantum entanglement spooky action at a distance. So good luck to us all. Here's proof that I too exist in multiple states. Serious physicist and whatever this is. So, my name is Adel. I'm currently pursuing physics as an undergrad, and I'm deeply passionate about theoretical physics, especially quantum mechanics. To me, physics has always been about uncovering the hidden rules of reality. But quantum mechanics has taken that to a whole new level, one where intuition breaks down, and where the impossible becomes possible. I remember entering my first quantum mechanics class at university. I thought I was prepared for anything that would come my way. I'd aced calculus, I'd memorized Newton's laws. But nothing, and I mean nothing, could prepare me for the whiplash of that first lecture. To begin, we looked into the wave function, a mathematical ghost that doesn't tell us where exactly a particle is, but where it might be. Probability, not certainty. And then we went to look at the Schrödinger equation, a formula so elegant that it felt like eavesdropping on the universe's private conversation. Later that night, hunched over a problem set, it hit me. Quantum mechanics isn't just about particles. It's a language for asking better questions. What if light were both a wave and a particle? What if certainty is an illusion? What if observing a world changes it? Today, I'll walk you through the topic of quantum mechanics, the technologies we've made through quantum mechanics, and how we can carry the momentum on to the next generation of scientists, engineers, and innovators to build a better and brighter tomorrow. So, let's address the elephant in the room. What exactly is quantum mechanics? Quantum mechanics describes the behavior of particles, matter, and energy at the smallest scales. It's levels of atoms and subatomic particles. Unlike classical physics, which tells us that the world works in a predictable, deterministic manner, quantum mechanics tells us that the world is filled with uncertainty, and it's governed by probabilities. At its core, quantum mechanics is built on three key principles. Wave-particle duality, where a particle can behave as both a wave and a particle. Superposition, where a particle can exist in multiple states at once. And entanglement, where two particles can be directly connected to each other, even across vast distances, directly correlating as a result. I know this isn't one of the key principles of quantum mechanics, but I found this really fascinating, and I'm really excited to show it to you guys. This is called quantum tunneling. Imagine a hill right over here, and a ball approaching that hill. You would imagine that the ball would go over the hill and then down again. I mean, that's how it works, right? Wrong. In quantum mechanics, the ball tunnels straight through the hill with a probability, vanishing on one side and reappearing on the other. These strange principles seem to be purely theoretical, but in reality, if we did not discover these quantum principles, modern technology would not exist. From the devices in your pocket to the most advanced lab equipment we've got, quantum mechanics has shaped the world in ways we often take for granted. I mean, take a look at this laser, for example. It relies heavily on quantum principles, revolutionizing medicine, communication, and even industry. Even MRI scanners, right, like the one right over here, used in hospitals worldwide, are based on quantum physics. But there's something really wild. We are no longer just applying quantum mechanics. We are actively engineering quantum technologies. And at the forefront of this revolution is quantum computing. I mean, take a look at this quantum computer right over here. Looks really pretty, right? Can just hang it on the ceiling like a chandelier. Imagine a computer that doesn't use bits, but rather it uses qubits. It can be zeros and ones at the same time, thanks to superposition. They can be entangled to each other through quantum entanglement, creating faster and much more efficient algorithms and ways to solve problems than classical machines would ever. All right, take a look at this Google Quantum AI's Willow chip. Smaller than a palm, but here's what it did. First, it solved the problem of quantum error correction. Add qubits, errors don't just drop. They vanish exponentially. Second, it solved the problem of random circuit sampling in 5 minutes. For supercomputers, 10 septillion years. Take that in for a second. 5 minutes versus a trillion years. That's even longer than the age of the universe itself. How does this change everything? You might be asking. Drug discovery can be accelerated by 10 times and modeled atom by atom. Climate change solutions would be created through precise detail. And AI, not only smarter and faster, but also self-optimizing. But the quantum revolution doesn't stop there. We can create unhackable networks with quantum cryptography. Room temperature superconductors with quantum materials. And quantum sensors that could predict earthquakes with atomic precision. But here's the big question. Where do we go from here? Quantum mechanics has already changed our world in ways we couldn't imagine possible. But the truth is, we've only just started scratching the surface. The real problem, and perhaps opportunity, is figuring out how we can use these breakthroughs, take them to a much higher level, building a better future and a brighter tomorrow. The quantum era isn't coming. It's already here. So if we get the next steps right, we don't just change technology. We change everything. Because this is not just another technological shift, which it is. This is a paradigm shift. Quantum mechanics has challenged how we perceive our reality. Particles that exist in multiple states at once. Information that can be teleported across vast distances. Computers that can perform functions in efficiencies and speeds that we could have never imagined. For centuries, scientists was all about certainty, about reducing problems to their smallest, most predictable parts. But quantum mechanics tells us that that's wrong. Certainty is an illusion, and the only constant is possibility. So the future won't be built by those who seek rigid answers, but would rather embrace uncertainty. And that is where you come in. The quantum revolution is happening everywhere across the world. It's happening in labs, in universities, in tech startups, and even in the minds of people who are willing to ask bold questions. But yet, despite all of the progress that we've made in quantum sciences and technology, we are facing a crisis in education and accessibility. The quantum era is moving so fast that we risk losing an entire generation of thinkers, creators, and innovators. If we don't make this right, if we don't do something about it, we might wake up to a world where only a few institutions control the progress of quantum, and while the rest of us just simply watch from the sidelines. That cannot happen. Quantum revolution should be for everyone, not just for physicists, not just for tech giants, but for students, entrepreneurs, and problem solvers from every field out there. That's why quantum education matters now more than ever. Of course, we have platforms like Coursera and Udemy that offer tons of courses in quantum mechanics and even crypto. No degree required, just curiosity. Spend 20 minutes a day and you would find yourself not just watching the future unfold, but actively building it. However, although that is the case, we still need more universities to open courses in quantum sciences and technology, more open source tools for the general public to experiment with quantum algorithms, more collaboration between scientists, engineers, and innovators. Because if we fail to make this knowledge accessible, we don't just slow down quantum progress. We limit the potential of what this revolution could achieve. So I leave you all with a challenge. Don't just be a spectator of the quantum era. Be a participant. You don't have to be a physicist to be involved. If you're a software developer, learn about quantum programming. If you're an engineer, learn how quantum materials could change your field. If you work in cybersecurity, learn about quantum cryptography. And if you're just someone who's deeply curious, start asking questions. Because it is the right questions that gives rise to revolutions like this. Ladies and gentlemen, we are standing in the dawn of the most profound technological shift of our lifetime. So the final question here is, are you ready to shape it? Thank you.